Okay, let's start with our first graph. We want to graph y equals 3 sine pi theta over 2. Okay? So, first thing you're going to want to do to get to the graph is identify which one are you looking at. Okay? Looks like we have a positive sign, so our graph's going to look like this. And I would do myself a rough sketch right by your graph on each of these, so you know what the points are that you're trying to sketch out right away. Okay? Once you have what your graph's going to look like, the next thing is you're going to need to find out what your amplitude is. How high, how low? Well, we know this thing's going to go as high as 3 and as low as -3. It's going to go up 3, down 3. So we know where this thing starts. It starts at 0. It's going to go as high as 3, as low as -3. And now we know we only need to know what's the distance between the first and the last point. Okay? Now that would be the period. Okay? So our period, we had a formula that was 2 pi over b. Okay? Now here we have a value of b right here. This is 1 theta, and b again in your equation, y equals a sine b theta. So here, b is the number in front of theta. Well, this is actually 1/2. So in this case, this is pi, or 2 pi, divided by 1/2. So when you divide by a fraction, you multiply by the reciprocal. So this is 2 pi times the reciprocal of 1/2 is 2. So this is 2 times 2 pi, which is 4 pi. So our period here is 4 pi. So that means the distance between our first and our last point is 4 pi. Now, we can go ahead and start looking at sketching our graph. We know our first point we're going to sketch is going to be where it starts, which is at 0. Now the next point you're going to graph, this is going to be the first point you graph. The second point you're going to graph is going to be the last point. Okay? Now, 4 pi, our graph only goes to 2 pi. That's a problem. We're not going to be able to graph this whole graph. Okay? Because between 0 and 2 pi, that's the only thing we have on our graph, and even from our equation, we're only supposed to see half of it. So we're not going to get the whole graph on here. So what would be the next point that we would plot? We would go to the middle, because this point should be in the middle of 0. This is 0, and this is 4 pi. So what's the middle of 0 and 4 pi? That would be 2 pi. Well, does 2 pi fit on our graph? It sure does. So we can plot this point. So there's a point on our graph. So our first point fits, and our middle point fits. Now, where's this point compared to these two? It's in the middle. Well, what's the x-coordinate between 0 and 2 pi? That would be pi. So at pi, we are up at +3, because our amplitude is +3. So we're going to go +3. That's right there. So here, our graph's going to go up to +3, and then down to 2 pi. Okay? Now, how much of this entire graph does this represent? Well, that's just half of it. Well, isn't b in this equation the number of cycles between 0 and 2 pi? Well, b was 1/2, so we only anticipated seeing 1/2. Now, on the examples, on these graphs, it says graph between 0 and 2 pi, or at least 1 full cycle. Since we don't have a full cycle, what I'd like you to do is to sketch the rest of the graph over here. So what we're going to do is we're going to take this the opposite way. So at -pi/2, we should be, actually not -pi/2, at our next point was at pi here. So at -pi, we are going to be down here at -3. So -3, we're at -pi. And then all the way over here at 2 pi, which is a little bit off of my graph, it should fit on your graph, we're at 0 again. So the graph comes down and then back to 0 at 2 pi. Okay? So here's a full cycle, but between 0 and 2 pi, we could only get half of the cycle in. Okay? So in the next video, I'll do example number 2.